This call is now being recorded.
Stop recording, share the screen, the entire screen. Okay. Okay, class, again, can you see my presentation?
Can.
Okay, very good. So I think we can start our online class now, yeah? Okay. Last week, okay, I asked you to finish the workbook exercise page 77 until page 78, okay? 77 to 76. Yeah, 76, 77, and 78. Is there any problem? Do you want, if you have any question, I think you can ask, now. You just tell me the page number and then the question number. How about page 76? I think page 76 is quite straightforward. Okay. 7.1, the type and sources of energy. Okay, right. No problem, right? Yeah. Number one, okay. You try to identify the various form of energy. Any problem? Number one. Question number one, page 76 on your workbook. Is it okay?
No.
No, no problem.
Okay.
Okay, right. Okay, good. You just choose the correct energy. Okay, you just choose the correct energy with their explanation. For example, 1A is gravitational potential energy. All right, and then the answer is already given, so you just choose the correct answer based on its explanation, right? Okay, number two, also very easy. You just choose the correct answer based on it, based on the sources of energy. Okay, so I think page 76 is okay. Excuse me. Right. So page 78, page 77 and page 78. Actually, you need to do an experiment. I already give you some of the video for you to watch in order to what we call further understand the existence of electrostatic charges, right? Okay, I just show you like this. Sorry, okay. The observation, page 77, yeah. The observation. What happened to the small bit of paper, empty aluminium, and fine stream of water are attracted to the balloon? I will show you some of the link that I have tried to find on the internet. Okay. Okay, can you see my presentation right now?
Can.
Okay, very good. Later I will give you the link for you to try it for yourself. All right. Okay. You must understand every object. Okay. Every object on their surface has its own charges. Okay, has its own what we call electrostatic charges. Okay, what are the charges? The charges here is either positive, positive charge or negative charge. Positive, or we call it proton, and then for negative we call it for negative charges we call it what?
Newton.
Neutron, a neutron or electron?
Neutron.
Neutron, right? Neutron or electron? Okay. Sorry. Okay. Positive we call it proton, and then negative we call electron. And then when the number of proton and the number of electron is equal, then we will have neutral charges. Okay. Every object that in the world. Okay, for example, like this, we have here one balloon over here, and then we have the we'll call a wool coat. The cloth here, clothes on my left is made from cotton wool. Okay, clothes on my left is made from the cotton wool. Okay, what happened? There is a electric static. We can see the electric static when the electron, okay, when the electron, or what we call negative charges, jump from one object to another, jump from one object to another object. Okay. Okay. Right now, what is the charges on the cotton wool there? The cloth, the charges on the wool, negative, positively charges, negatively charges, or neutron. Here, this one, the cloth, positively charges, negatively charges, or neutral?
Neutral.
Neutral. Okay, very good. Yes, correct. It is neutral because it has same amount of electron and proton. Proton is positive charges, and then electron is negative charges. Okay, when there is neutral charges, nothing will happen. Okay, if I try to move the balloon here, balloon also have neutral charges, and then the wall here also have neutral charges because it has equal what? Equal amount of electron and proton. Positive and negative are equally, the quantity is equal. Okay, so what happened? Okay, when I move the balloon, okay, when I move the balloon to the cloth over here, meaning that I introduce what we call a friction. I just rub the balloon, all right? The balloon is made from plastic or from rubber, right? And then I try to rub it on the what we call on the cloth. What happened? Can you see what happened? What happened when I rub the balloon to the cloth? What will happen? Yes? I can't hear you. What happened when I rub the balloon with the surface of the balloon? I rub it with the woolen cloth. What happened? What happened to the charges?
Negative go to balloon.
Yes, the negative charge on where? The negative charge on the woolen coat or the woolen cloth there will jump or will transfer to the balloon. Okay, will transfer to the balloon. Okay, because there is a friction. Because there is a friction, the electron will jump or will transfer from the cloth to the balloon. And then what happened to the cloth? The cloth become what type of what charge of object?
Positive.
Okay, very good. Correct answer. The cloth, right? The woolen cloth will become positively charged. Okay, and then what happened to the balloon? The balloon will become,
Negative.
yes, very good. It will become negatively charged object. Okay, and then what will happen if I pull the balloon over here, and then you can see if I release the balloon will start to stick to the balloon will start to adhere or stick to the cloth. You see, when I release the balloon, it will stick to the cloth. Okay, you must remember what happened, because what is the interaction between charges? Yeah, if negative and positive, different charges, it will repel or it will attract.
Attract.
Yes. Okay, when what we call different charges, it will attract. Okay, and then when there is a same charges, it will repel. So what happened to the balloon after I rub it with the what we call with the woolen cloth? It will attract to the woolen cloth, because the positively charges on the woolen cloth is positively charged, and then the balloon become negatively charged. Okay, so the balloon will attract to the woolen cloth. Okay, this is what happened when we what we call rub two different objects together. Okay, can you understand this? Okay, if I touch the balloon into a pieces of paper, if I have here, for example, pieces of paper here, this is just a pieces of paper. What will happen to the pieces of paper when I take the balloon to the pieces of paper over here? What will happen to the pieces of paper? Okay, this is the pieces, just a pieces of paper lah, down here. For example, here, this is just a pieces of paper. Okay, pieces of paper are negatively charged, positively charged, or neutral? Class. Yeah, the pieces of paper, negatively charged, neutral, or positively charged?
Neutral.
Neutral, right? Neutral means it has same amount of electron, same amount of positive charge, and same amount of negative charge. So what will happen to the pieces of paper if I take the balloon near the pieces of paper? What happened to the pieces of paper? The pieces of paper will attract to the balloon. Okay, will attract to the balloon. Okay, can you understand the transfer of electron, the transfer of charges? The transfer of charges. This is how what we call the electron, the electrostatic, we try to is being detected. Okay, when the charge is moving, all right, when the charges is moving, so we will have, it will produce electrostatic charges, or it will what we call produce electrostatic charges. Okay, when there is a friction between two objects. Okay, maybe kalau if two same object with the same amount of charges, maybe it is not too common. Okay, but if you try to rub a balloon or plastic through a woolen cloth, then we will have a very significant or large number of electron transfer from one object to another object. Okay, usually when you use woolen cloth and plastic, or the balloon there, or the rubber, the transfer of electron is much bigger, right? Okay, so I will try to use another example. Okay.
and welcome to Fun Science Demos. Check
Okay, can you see the video?
this out.
I didn't expect you to hear the voice line, but I hope you can see the video for yourself. Okay. So I will just keep to the important things here. So if you identify here, if you notice there is a balloon here, there is a balloon here, okay, and then there is a woolen cloth here, okay. So if you try to rub the two objects together, the electron will transfer from where to where? Usually the electron here, the negative charge will transfer from the woolen cloth to the balloon. Okay. What charges? Negative charges. Negative charges is what? Negative charges is the negative the electron. Electron will transfer from the woolen cloth to the balloon. Okay, when you rub two objects together, right? Okay. So again, let me continue the video. You can do the experiment at home. Or if you do not want to do it, you just watch the video. Later, I will give you the link, yeah? Okay. Okay. The guy over there rub the balloon to the what we call to the balloon. And then they use what? They use the aluminum can over there. What happened to the aluminum can? Okay, what happened? See next. Attract or repel, you think? The aluminum can. It will attract. So what happened here? Okay. If you use the balloon, again, if you use the balloon, okay. Now, after the woolen cloth and the balloon has been rubbed together, what happened to the balloon? Balloon now positively charged or negatively charged or neutral class? What happened to the balloon after it's been rubbed? Negative or positively charged?
Negative.
Negatively charged. Huh? Where the balloon got the negative charge?
From the clothes.
From the cloth. Very good. From the cloth. Huh? So what happened to the woolen cloth over here? Woolen cloth will be positively charged or will become negatively charged?
Positive.
Yes, the woolen cloth will become positively charged. Okay. Why the negative charge from the woolen cloth jump or transfer to the balloon? Why? Because of what action? Why the negative charge from the woolen cloth jump to the balloon? Why? Because what is the guide? Yes, friction, yeah. Or the guys over there rub the balloon with the woolen cloth. When there is a friction, when the balloon rub to the woolen cloth, the charge will transfer. Okay, now the aluminum can over here. What is the charges? What is the condition of charges of aluminum can here? Negative charge, negatively charged, positively charged, or neutral?
Neutral.
Okay, very good. The aluminum can over here is neutral, but at the balloon right now, it has too many negative charge. 1, 2, 3, 4, 5, 6, 7, 8. I just write 8 on the line, and then maybe about a few positive charge here. And then what happened to the woolen cloth? Woolen cloth, maybe we have 1, 2, 3, 4, 5, 6. Maybe just only 3. Okay, so this is positively charged at the balloon, and then at the woolen cloth we have not positively charged. What it is at the balloon? Balloon it will become negatively charged, and then at the woolen cloth we have positively charged. And then at the aluminum can over here, maybe it has the same amount of charge. Huh? Same amount of charges. So okay, same amount of charges. Negative, positive. Can you see the drawing over here, class? Can you see my drawing? I hope you can see it, yeah?
Can.
Okay. Aluminum can, we have equal number of negative and positive charges. Okay. And then at the balloon over here, it has a negative charge, meaning that negative charge is more than positive charge. Okay. Why do you think the aluminum can attract to the balloon? Why? It will follow the balloon. Why? What do you think? You look at the amount of negative and positive charge on both objects. You look at the amount of charge. Balloon, how many negative charge? 1, 2, 3, 4, 5, 8, right? More than positive charge. Positive just 3 charge. Okay. How about at the aluminum can? Aluminum can has equal amount of positive and negative charge. Okay. For example, at aluminum can here we have 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 7 lah. And then negative also 1, 2, 3, 4, 5, 6, 7. We have 7 positive charge and 7 negative charge on the aluminum can. Okay. On the balloon, we have 8 negative charge, but only 3 positive charge. So what happened to the aluminum can? The aluminum can will attract to the balloon. Because why? Because the amount of positive charge in aluminum can is 7, and then the amount of negative charge on the balloon is also about equal. It's also about equal. Okay. Sorry, not the amount of positive charge in aluminum can. I just add another one for you to understand it further. Same. Okay. Great. All right. Never mind. Okay. Negative. We have also has 8 negative charge here. Okay. Right. Aluminum can has 8 negative charge and then also have 8 positive charge. We'll call it neutral. Okay, we call it neutral. And then at the balloon, we have, I just erased it a bit for you to see the difference. Okay, at the balloon, we have 8 negative charge and only 3 positive charge. Can you see the difference in amount of charges? Okay.
Can.
Yeah. Balloon only 3 positive charge. Okay. Balloon only 3 positive charge. All right. And then at the aluminum can, we have 8 positive charge on the aluminum can. Okay. Can you see the difference? Right. So what happens when there is same polarity? If positive and positive, it will repel. Negative and negative, it will repel. But positive and negative will what? Positive.
Yes.
Yeah, positive and negative charges, it will
Attract.
okay. The opposite. If positive and negative, yes, it will attract each other. So according to the amount of charges here, because the number of positive charges on the balloon is less than the number of the positive charges on the aluminum can. So the aluminum can here will attract to the balloon. Okay, because at the balloon there are only 3. For example, here there are only 3 positive charges. Okay, the amount of what we call positive charges on the aluminum can is 8. So more than the balloon. The charges, the positive charges on the aluminum can is more than balloon. So what happened to the aluminum can over here? If we try to, again, I will show you the video. Okay, you see, it will attract the aluminum can here. Okay, so this is the first example. Next one, the flow of water. Okay, can you see the video? Later I will give you the link lah, for you to see again. Okay. Okay, what happened to the water flow? What happened to the water? The water will what? Okay. What happened to the water flow?
To the balloon.
It will attract to the balloon what? Okay, again, I will try to draw you again this picture, right? Okay. First, when the guy over here, the water from the glass here will flow straight down. It will flow straight down here. Because of the gravity, right? It will just go straight down over here. Okay? So you must remember, every object has a negative and positive charge, right? So I want to ask you, what is the charges on the flow of water over here? Is it positive, negative, or neutral?
Neutral.
Okay, it is neutral. Okay, very good. It is neutral. And then what is the condition of the balloon? Positively charged, negatively charged, or neutral at the balloon?
Negative.
Yes, at the balloon is negatively charged. Okay, where they get the negative? When they rub the balloon with the woolen cloth. Right. Okay, you see what happened next, yeah? All right. Can you see what happened? This is the original, This is the original flow of the water, before the guy over here take the balloon and then put it near the flow of water. And then what happened? After put near water, the flow become what? What will call this? The water bent. The water bent towards the balloon. So the flow of the water attracts to the balloon because why? Because of the same reason. Okay, because of the same reason. Okay, there is the quantity of positive charge in the flow of water is more than the quantity of the positive charge on the balloon. So the flow of water will attract to the balloon. Okay, can you see the difference here, class? Okay. I think I need for you to do the experiment yourself and then you take the video. Can? Boleh kan? Later, I will decide later. Okay. Right. This is if you use the flow of water. Okay. Next one. This is a very common what we call experiment lah. Yeah. You try to rub any object, plastic, to the pieces with the woolen cloth, and then you will see that the pieces of paper will attract to the plastic. Okay, is it okay, class? Can you understand this? If you can understand this, then you can answer the question over here, page 77 and 78. Okay, right? If you have any question, you can ask me. Okay, next one, I will show you electroscope, how electroscope happen. Okay, this is electroscope. All right, this is the example of what we call an electroscope. Okay, class, see here. You must try to understand the component of electroscope first. Okay, the component of electroscope. I just want to show you the real picture of electroscope. Electroscope. Okay, this is example of electroscope actually. There is an electroscope in the science lab, but we cannot show you the real things because you cannot come to the school. Okay, actually there is what we call just a piece of metal over here. Okay, pieces of metal over here. This is a cap, metal made from the metal, and then there is a rod up, down until at the center of the container here. Okay, just a piece of metal. Okay, this is the metal cap, and then inside the metal cap there is just what we call a metal here. And then if you can notice, there is a gold leaf. It can be gold, it can be a pieces of paper over here. Over here, it can be gold or it can be a pieces of very thin paper or very thin gold here over here. Okay, and then when there is no charges detected, or when there is a neutral charges, the what we call the paper, thin paper over here, and then the leaf paper does not open or does not diverge. Okay, does not diverge. All right, when there is a neutral charges. For example, right now, the charges around the metal cap, the charges around the metal cap, and then the charges around the what we call the gold leaf here is neutral, right? Same number of electron and proton, same number of positive and negative. So the leaf here do not open, do not diverge. Okay, it will do not open, it will not diverge, right? Okay, so like the picture on your workbook here. Okay, this is the what we call the gold leaf or the thin piece of paper, and then this is the metal. When you put a neutral rod, nothing happen. It will do not open. It will do not become like this. It will not open because the charges is the same charges, or neutral. All right. So what happened if what happened if I put negatively charged object, for example, the plastic rod that I have rub it with the woolen cloth? What will happen? You can see the simulation here. What will happen? It will open, right? It will diverge. Okay, why? Why it will diverge? Can you still remember what happened when same what we call charges, same charges, it will attract or repel?
Repel.
It will repel, right? Metal cap over here, the metal cap over here, and then the gold leaf over here is neutral because it has the same amount of charges. Metal cap and then the gold leaf over here, same. Same amount of charges. We call it neutral. And then what happened when we put put the negatively charged object near? What happened? It will repel, right? The negative will repel the negative rod from the what we call from the rod here, will repel the negative charge from the metal cap down until what happened? Until the charge going down, the negative charge going down, and then it will repel it will what we call diverge the golden leaf. The gold leaf, inside the container. See? Right? Can you see it? Can you see the difference? Why the inside here will open? Because there is too much what? There is too much negative charges, right? Negative charges too much, it will diverge. Diverge means it will open. Okay, never mind. I will copy this to our Telegram group. And then if we touch this, what happened? If we touch, what happened? Nothing happened lah. Right. If you just use the hand, nothing happened. Why? Because our hand is also neutral. The metal cup, the metal cap over here is also neutral. So the object, the gold leaf inside the container will not open. Okay. So if we use positive charge, what happened? If you use positive charge, it also diverge. All right. If you positive, it also diverge out. All right. Okay. So you go back to the question. Okay, positive charge rod, then it will diverge, and then if you use negative charge rod, it also diverge. Because electron is attract to the what we call the negative parts of the positive rod. And then if you are using negative rod, the electron on the negative rod will attract to the gold leaf inside the electroscope. Okay. Okay. So, any problem? Now it's 1:23. Can you understand this? Never mind. I will try to give the link for the video and simulation on our Telegram group, right? Okay, so right. So any question before I stop here?
No.
No question, yeah? Make sure, right? Make sure you try to finish page 70, 77, 78, 70, and then for today exercise, just continue to page 79. 79, page 79 on your workbook. And then we continue tomorrow, not tomorrow. We will continue the class on Wednesday on the next topic. Okay. Like usual, if you have any question, you can ask me on our Telegram group. Okay. Is it okay, class? Please ask if you do not understand certain topic. Please ask. Okay. So now it's 1:30 in the. All right. So that's all for today. I hope you understand. We see you all again on Wednesday. Thank you for your attention and focus. Bye-bye. You can leave the class now. Bye.
Thank you, teacher.
Thank you very much. Bye-bye.
Cheers.
Thank you.
Bye-bye.
Bye-bye.